Hello, everyone! Welcome to the Wings Engine Water Settings Series tutorial. Earlier, we looked at our flat water and our waveform simulation water. Today, we will look at the last type of water, which is based on the diving equation. To simulate water based on physics. This kind of water is different from the other two. Its usage is actually very different. The other two types of water are generally used to. We used it too. To display a static page, such as a static water surface, such as the upper part of a dam, and the effect of a reservoir. But the second type of water, we show a more dynamic water surface. Whether it is building a dam, such as releasing water, or floods that flood towns, are all realized by our water. Of course, our more common way should be offline water management simulation. Then we can display the simulation results in real time on our screen. I will explain it in the later course. This requires when we are working on related projects. We need to do an offline water simulation to predict the depth of the water and changes. And our Wings engine provides a relatively simple, with less accuracy, but it's basically sufficient to simulate the water flow in real time in the picture. A physical simulation of the water surface. This is a WebGL called the diving equation. Diving equation. Okay, let's take a look at this diving equation. How to set the water of the diving equation simulation. Okay, we can see that in the entire picture. I've actually placed one. I'll delete this first. We actually demonstrated it to you in the first class. The entire diving equation. Today, we'll take you to set it up together. This is the diving equation. First, we still select Insertion box. Find a section called Diving Simulation. We click on it. Okay, at this time, it'll give me a square like this. Note that. Diving simulation has a range. And the larger the range is, the worse the overall performance is. The worse its performance is. The diving equation is a very, very computationally intensive. So why do I recommend that? Normally, it should be an offline simulation, not like our real-time simulation, only when we need it, for example, to show the water flowing in different terrains. What the water flow will look like. These more real-time scenarios we can use our diving equation here because we need to simulate the effect of the dam's water flow. Such a large box is obviously not enough. So we need to first make the frame larger. We can change the frame size directly here. However, we need to pay attention to this because every time we change it here, it will change. So I suggest that you to type the number out in another place first and then copy it directly so it won't be too laggy. When directly changing this value, it may be a bit laggy. When dragging this, it will be stuck. Here we are 64 meters. At most, I recommend that you not to exceed 1,000 meters. Let's use 512 meters today. Let's type in 512 here to prevent it from being too laggy. Let's just paste it in. Okay, paste it in. 512 is actually relatively large, but it requires some patience. As you can see, this is actually a relatively large box. It's a range. So why do I recommend that you remember to copy it in? Otherwise, if you just drag it, it might really get stuck. Or it may be very stuck. Okay, let's roughly adjust the position of this box. Okay, like this. That is to say, the entire water can only flow to this point. It can't flow here because it can only be simulated within this box. This is our first point to note. Moreover, when we simulate, there is also a simulation accuracy. We set 1 here. Then the flow of water may be relatively less accurate. For such a large box, we may need to set 2 or 3. But everyone should adjust it. Computer's performance. To make a setting. Let's keep 1 here first. Let's first take a look at the overall effect. After we pull it up, we need to check. When we expanded the diving simulation, we can see there is an outlet. This is very important. Then our water will eventually flow out from this water outlet. Let's adjust the position of this water outlet first. We adjusted it to this, just below the dam. Look at the top view. Adjust it to the bottom. Everyone pay attention. This water outlet point can't be in the same room. Because if it's in a room, it would be inaccurate. Okay, this is the second point. We need to adjust the position of the water outlet. The third point is, pay attention in the GIS scene. Because of GISS, because C has already integrated, and so on. However, C doesn't support rendering multiple cameras simultaneously. So for GISS, a relatively simple way is we give a function called snapshot GIF depth. That is, we took a snapshot here. First, we see the entire picture. We click on the GIF depth. We save the entire image. The GIF depth in this box. Only in this way, because when we zoom out the GISS, it has a light dark transition. So when we zoom in or out, this the depth is inaccurate. So it's best to take a screenshot when zooming in. Second, as I mentioned earlier, because it doesn't support real-time capture. Because every real-time phase. To switch to a top view camera, which is very. Okay, let's start the simulation. We need to click here first to take several depth screenshots. Okay, after all the preparations, let's start the simulation. You can see the water is flowing from our entire. Slowly flows down from the water outlet. We can move forward a bit. The flow feels quite right. But we can see that the whole water is not so fine relatively. It's because our precision is not high. You might think that the water, it can't flow so slowly. So do we need to make it faster? We can increase the update speed, such as 15. Okay, the water will flow much faster. One way, take a look at the flooding effect here. As I said before, after it reaches the edge, it will not simulate anymore. If you want to simulate the entire area, such a large area, we need to make the box bigger. This requires your have better computer performance. Actually, we can adjust the position of the water outlet. It can release water in different places. Okay, we can see that water can be released here. Let's zoom in. Meanwhile, the water outlet. This is a square. We can also make it smaller, like 2. Okay, you can see this water outlet. It will be discharged in a different way. Let's change it here. As long as it's in the entire picture, it's okay. The same is because we have this material here. We can also adjust this material. The material is a little darker. For example, if we want to really simulate the effect of a flood. Okay, we can make this dry yellow first. This one. This is very similar to the material. Is very similar to the one we used in the last class. At the same time, we can also lower the transparency. Otherwise, it doesn't look like a flood. Now it looks like a flood. Okay, let's assume that we don't need to simulate it anymore. We can pause the simulation and reset the simulation. Then this image will disappear. We can use this method too, because our entire the diving simulation can be controlled by interaction. I will explain it in the later course. How I use buttons to control the entire water. Start simulation. Stop and start the simulation. We can see that we have stopped the simulation now. We can adjust the water outlet point a little bit and bring it back to the previous position. Just a little bit. Everyone check it carefully, because this space is more complicated. Let's look at it from various angles. Let's come back and take a look again. Let's start the simulation again. Of course, I just adjusted the colors randomly. It might be. It's still a little green. In the end, we should make it a little more yellow. If it's not yellow enough, a little more yellow, then the whole feeling will be more like a flood. Maybe we can make it a little more, and even a little more towards oranges. The overall feeling will be more like a flood. Okay, in this class, we will to see how the effects of our diving simulations, how the effect is presented. Okay, we can put this data point on the mountain. We can see a more obvious feeling. This feeling, when our flood is submerged, what it will look like. Okay, that's all for today's class. Thank you all.